Picture the darkest sky you've ever seen. But what if I told you that darkness isn't empty? What if every single patch of black you've ever looked at is actually packed, absolutely overflowing, with galaxies, stars, and worlds? What if the night sky isn't showing you the universe, but hiding it? But here's the thing. That sky is wrong. Not poetically wrong, scientifically, mathematically, fundamentally wrong. And the reason it looks the way it does is one of the most wild detective stories in the history of human thought. One that ends with a universe 10 times bigger, 10 times more crowded, and 10 times more invisible than anyone ever dreamed. Let's go back to the beginning. It's 1823. A German astronomer named Heinrich Olbers is doing what astronomers do, staring at the sky and thinking uncomfortable thoughts. And the uncomfortable thought he lands on is this: if the universe goes on forever, packed with stars in every direction, why isn't every single point in the sky burning bright? Think about it like standing in an infinite wheat field. No matter which direction you face, eventually your line of sight hits a stalk. In an infinite universe, the same logic applies. Every line of sight should hit a star. The entire sky should blaze like one giant sun. Day, night, it wouldn't matter. The sky should always be on fire. But it's not. It's dark. And that darkness, which we'd always taken for granted, was suddenly the most baffling thing in science. This became known as Olbers Paradox. And for over a century, no one could crack it. The universe was hiding something, and the darkness was the only clue. The first suspects were predictable. Scientists said, maybe cosmic dust is blocking the light. Like fog diffusing headlights, maybe enormous clouds of gas and particles between us and the stars are simply soaking up all that energy before it reaches our eyes. Reasonable, clean, and completely wrong. Here's why. The first law of thermodynamics doesn't negotiate. Energy cannot disappear. When dust absorbs light, it heats up, and hot things glow. The dust would re-emit all that absorbed energy as infrared radiation, filling the sky with invisible heat. You'd swap a glowing sky for a glowing sky, just in a frequency our eyes can't detect. The paradox would still exist, just out of our visual range. Back to square one. Then came the fractal theory, the idea that the universe isn't smoothly packed with stars, but arranged in a kind of hierarchical clustering, like nested groups of groups. Zoom out far enough, and the density keeps dropping, meaning your line of sight eventually finds empty space rather than a star. Elegant, but also wrong. When astronomers mapped the cosmic microwave background, the faint afterglow of the early universe radiating equally in every direction, it shattered the fractal model. The universe, on the largest scales, is remarkably smooth. The paradox survived. The answer, when it finally came, would require dismantling everything humans had assumed about the universe itself. The first real breakthrough came not from gazing deeper into space, but from realizing that space has a history. The Big Bang theory established that our universe isn't eternal. It began. Roughly 13.8 billion years ago, everything, all matter, all energy, space, and time themselves, burst into existence from an infinitely hot, infinitely dense point. This single fact demolishes Olbers' original setup. Light travels fast, 300,000 kilometers per second, but it doesn't travel instantly. So the light from a star 20 billion light-years away hasn't arrived yet. It's still on its way. It hasn't had enough time. This creates what cosmologists call the observable universe, a cosmic horizon roughly 46 billion light-years in every direction, larger than 13.8 billion because space itself has been expanding while the light traveled. Beyond that boundary, the universe might extend forever, but we're blind to it. The light from out there hasn't found us yet, so Olbers' infinite forest doesn't quite apply. We're not standing in an endless sea of visible stars. We're standing in a very large but finite bubble, surrounded by darkness that isn't absence, it's delay. That was huge, but it still wasn't the whole answer. In the 1920s, Edwin Hubble made a discovery that quietly broke the brains of every physicist alive. Distant galaxies are moving away from us, not because they're flying through space, but because space itself is stretching, like dots on the surface of a balloon being inflated. And here's where it gets really strange. As a galaxy races away, the light it emits gets stretched along with the fabric of space. Think of sound waves from a retreating ambulance. The pitch drops as the source moves away. Light does the same thing. Its wavelength stretches. It shifts toward the red end of the spectrum. This is called redshift. For the most distant galaxies, this stretch is extreme. Visible light gets pulled so far that it slides completely out of the range our eyes can detect, past red, into infrared, into microwave frequencies. The sky doesn't just look dark in those directions. The light arriving from those galaxies is real, energetic, electromagnetic radiation. We just can't see it. It's invisible to human eyes by the physics of cosmic expansion. The night sky isn't dark because nothing's out there. It's dark because what's out there has been redshifted into invisibility. But even this, a finite universe in an expanding cosmos, wasn't the final piece. The case had one more shocking twist. For most of the late 20th century, scientists estimated the observable universe contained somewhere around 100 to 200 billion galaxies. Already a staggering number. Already enough to make you feel appropriately small. Then, in 2016, astronomer Christopher Consolis and his team did something bold. They took 20 years of Hubble Space Telescope data and used sophisticated 3D modeling techniques to turn flat images into maps of galaxy density across cosmic time. What they found redrew the map of everything. The early universe, shortly after the Big Bang, was not sparsely populated. It was absolutely packed. Galaxy counts were roughly 10 times higher per unit of space than they are today. The universe back then was a chaotic nursery, swarming with small, faint proto-galaxies. Over billions of years, most of them collided and merged, cannibalizing each other to build the large spiral and elliptical galaxies we recognize today, like our own Milky Way. The revised estimate? The observable universe contains at least 2 trillion galaxies. Some models push it higher. That's 10 times more than we thought. And roughly 90% of them, the small, ancient, faint ones, are completely invisible to us, either because they're too dim, too small, or their light has been redshifted beyond detection. We have been aware of less than 10% of the galaxies that exist within our own observable bubble. So here's the complete answer to why the night sky is dark. 3 reasons stacked on top of each other like a cosmic conspiracy. 1. The universe had a beginning 13.8 billion years ago. The light from most of what exists hasn't had time to reach us. 2. The universe is expanding. The light that has reached us from the most distant sources has been stretched into infrared and microwave frequencies, invisible to our eyes, but not actually gone. The sky is flooded with light we can't perceive. 3. The vast majority of the universe's galaxies are too small, too faint, and too ancient to detect. 2 trillion galaxies, and we've only ever glimpsed a fraction. The darkness isn't emptiness, it's a veil. And here's where the story gets a new chapter. The James Webb Space Telescope, with its infrared-sensitive mirrors chilled to nearly absolute zero, is finally pulling back that veil. In 2024, Webb identified the most distant galaxy ever confirmed, JWST 140, a galaxy whose light left it just 290 million years after the Big Bang, arriving at our instruments after a journey of over 13 billion years. And in early 2026, that record fell again, to MOMZ 14, a galaxy seen just 280 million years after the universe began. Webb is also uncovering swarms of tiny, ancient galaxies that were completely invisible to Hubble, the very population Consolis's 2016 study predicted. Small, starburst galaxies, blazing with ultraviolet light, re-ionizing the early universe. Objects so faint and far they'd only ever been theoretical before. Now they're in our images. Every time Webb points at what looks like an empty patch of sky, it finds more. The emptiness is an illusion produced by the limits of human senses and the instruments we built before we understood quite how much we were missing. Here's what gets me about all of this. For centuries, humans looked up at a dark sky and felt alone, small, insignificant in an empty cosmos. And the actual truth is the inverse. The darkness isn't evidence of emptiness, it's evidence of scale, of a 13.8 billion-year-old expanding universe, packed with 2 trillion galaxies, most of which have been hiding in frequencies of light we were never built to see. Every patch of black between the stars is teeming with ancient galaxies. Every shadow is full. The universe isn't empty. We just hadn't built good enough eyes yet.